Alright, here we're going to have a look at algebraic fractions. Now, we've dealt with things like this. So I've got 16x over 4x. Now what's nice about that is I can say, well, I've got 16 divided by 4, which is 4, and x divided by x, which is 1. So I end up with 4 over 1, or just 4. Now the reason they're able to simplify it that way is because everything is multiplying one another. I have 16 times x and 4 times x, which means that I can, if they're all factors of one another, I can just straight away do my divisions throughout. I can go 16 divided by 4 and x divided by x. If I have something that, say, looks like this, 2x plus 8 over 2, I cannot just go, 2 divided by 2 and I end up with x plus 8. We haven't got the top fully factorized, so that's not the approach I can take. I need to, before I do any simplifying, I do factorizing. I need to get factors, okay? Then we think about simplifying. Simplifying or dividing through, but first we need it in factorized form. So you are going to use the different factorization methods that you have. We look for common factors and then we ask ourselves how many terms are there. Straight away here I look at the top and say that I have a common factor of 2 outside of x plus 4 over 2. Now here everything is now in factored form. I have 2 lots of that and I have 2 in my denominator, so I can simply say 2 divided by 2 gives me x plus 4. Okay, so if I can put brackets around everything, it means that everything is multiplying one another. Now if I have a set of brackets or a single term that is common to top and bottom, numerator and denominator, I can simply divide those through. Until you have factored everything, don't think about simplifying anything. Now this only applies if we have an addition in the numerator or an addition in the denominator. If you end up with something that looks like this, or let's say 25 a squared b over 15ab squared, well, that we don't have to factorize that because that is already in factored form. I have 25 times a squared times b squared, 15 times a times b squared. They're already factored, or in fact they are all factors of one another, so we don't need to go about this process over here. But if you've got any sort of addition, you need to do some factorization. You look for your common factors and then you use those few techniques that we learned. Let's have a look at another couple. Okay, so I've got 5x minus 15 over 3x minus 9. Don't you dare think about going and saying, 15 over 9 and simplifying that way until I've got brackets around everything and they're exactly the same pairs of brackets or terms. No simplifying. So we do our factorizing first. Favorite F word. Then we can simplify. Okay, we go 5 outside of x minus 3 in the numerator over 3 outside of x minus 3. And now what I see is that I have a common factor. X minus 3 divided by x minus 3. It's all in brackets. So I'm able to do this and I end up with 5 over 3. Okay, now a little tip to look out for. If you factorize the top, the numerator, and you get a factor, go looking for that factor in the denominator. Okay, when we start to throw a few more things into these, there might be lots of different factors, but go looking for the same factors when you're trying to factorize so that you can do as much simplification as possible. So they might not be there. In this case it was. Maybe we'll end up with x minus 3 and x plus 2, and there's nothing we can do with that. But if you've got one factor, go looking for it elsewhere too. Let's try another one. Again, we're factorizing before we simplify. I'm going to have a squared plus 5a plus 6 over a squared plus 4a plus 4. Do not dare. Do not even dream about going and saying a squared divided by a squared. Oh, they're the same, so I'll divide out. I'll get rid of those a's. That sort of thing will not happen here. Okay? They mean nothing to us in terms of simplifying until I have done this. Okay, let's go and factorize. So my top set of terms, I notice that there's no common factor, no a all throughout. For starters, let's pretend as though the denominator is not there. So my top set of terms, I've got a square, I've got an a, and then I've got a constant. It's a trinomial, so I'm looking for numbers that multiply to give 6 and add to give 5. Well, I'm thinking a plus 2, a plus 3. All right, denominator. Now, I'm looking for a plus 2 or a plus 3. Might be there in the denominator, might not. Again, it's a trinomial. I'm looking for numbers that multiply to give 4 and add to give 4. I'm thinking a plus 2 and a plus 2. So what can I do now? I can divide through because everything's multiplying one another and say a over 2, a plus 2 over a plus 2 is just 1. And then I end up with a plus 3 over a plus 2. Now please, again, that's as far as we can go. You can't go a over a, oh, and I end up with 3 over 2. That is not acceptable, okay? Unless it is in factored form, you can't simplify. If that were a times 3 and a times 2, different story. But if we have an addition, you stop. Part of this is knowing when to stop. Okay, I'd suggest watching the second video for another couple of examples, but if you're understanding this so far, you're doing well.